Hello, anyone? Someone? I already mentioned about the SIM and use in the data warehouse. So please, anyone who still remember can try to express it or try to answer it. It is okay to make mistakes.
Is it ETL, sir?
PL?
ETL.
Is PL a SIM? The SIM that being used in the data warehouse, especially this is similar with database design. Anyone else? The first letter would be S. There are two SIM. Both of the SIM are starting with the letter S. The one that shining bright in the night. The second letter would be T, and the second
Excuse
letter
me,
would
sir.
be yes.
Star and Snowflake.
Sorry,
Star and Snowflake. Like
snowflake. Please try to remember all the material. At least try to study all the material. Okay, okay. Thank you very much for all of your effort, whether it is correct or incorrect, and still appreciate all the effort. Please try to do so next time, so that I am sure that most of you will study well. Okay, today we will have a deeper explanation regarding to the SIM that is being used in the data warehouse. The the most popular SIM that being used is Star SIM and Snowflake SIM. Actually, there are more than two designs, but these two are very popular and being used oftenly for the database SIM design or the data warehouse SIM design. So before we jump into the material, I would like to remind you of to refresh your memories regarding to the ETL process. Basically, the ETL process was used to transfer the data from OLTP, online transactional process, and then being processed by the ETL, into data warehouse. Okay. And it can be enhanced into a data cube, and then both of them can be used into OLAP or online analytical process. Basically, what is the difference between the online analytical process and a regular report? The main differences would be the ability to do reporting. By having an OLAP, then you can do a reporting data inside the report without need to redesign your report. Wait a minute, I think I have a
Recording in
and then so the main differences between the regular report and then the OLAP or online analytical processing report is the pivoting ability, where the report can be changed dynamically without necessarily to refresh or to redesign the report. So the basic report usually will be static report, where you cannot change the view, you cannot change the data, you cannot change the style or anything else. But in OLAP, where because it has a pivoting ability, then the report itself will become more dynamic, where you can change the view, the data itself without necessarily to refresh the. So it is a very useful tools to be used for the middle management above. So today's topic we will be discuss about the star scene and then the snowflake scene, the two most popular scene used in a data warehouse. And then the part of the scene itself consists of two parts. The first part would be fact table, and the second part would be the dimension. So there is a differences between OLAP and OLTP. As I already mentioned, the differences would be the OLTP database design should be normalized. And for the OLAP database design should be the normalized. So we need to change the concept of the database from normal into the unnormal or not normal database design. Why? Why do we need to normalize the database for the OLTP, and then we need to denormalize the database for the OLAP? So the main concept for the normalization database would be the what's called redundancy, redundant. Redundant stand for the words of repeating. having the same data uh, in a single table or in a single data. So basically, it is not allowed for you to have multiple data or multiple similar data inside an OLTP because it will be confusing for the system to verify whether the data is correct or not. But unlike the OLTP database, the OLAP database is a special kind of a. We need those redundancy to make the system faster and efficient. So I will try to give you the example. Why do we need the redundancy data for OLAP, unlike the LTP where the redundancy data is forbidden? So basically, there are three SIMs to be used as a data warehouse. The two SIM are oftenly used. They are called Star SIM and Snowflake SIM. And for the third SIM, called Star Constellation, is rarely used because it's quite complex database, and usually the middle management do not need those kind of complexity. They need to simplify the information, so the star constellation quite confusing and quite difficult to be designed. So in this topic, we will only discuss about these two scene design. First, we will try to remember or memorize what is the normalized database really is. A normalized database usually will only consist of one-to-many relationship and one-to-one relationship. Okay. This is the symbol that being used to represent the relationship. The key is for the single or one relationship, and for the infinity symbol stand for the many relationship. So we can say that the relationship between customer and the sales order header would be the one-to-many. Where customer is one customer can have a multiple sales order header. And one sales order header will only consist of one customer, and so on. So having this kind of condition, if you wanted to know, if you wanted to know the customer transaction within months, you will need to join a multiple table. Or if you wanted to know the address or the specific or detail specific information of the customer, then you need to join multiple address, which is good for OLTP database where the data will not mix each other as the normalized concept being used. So as you can see that one person can become many customers. Why? Because even though that one customer represent one person, but sometimes a person can have a multiple customer ID. One of many reasons or the example is, let's say the person A was registered as a customer, and then he quit. And then the next year or next day or next month, he is trying to rejoining, or he is trying to register another member, while the policy of the company uh, cannot, or the policy of the company, everyone who is registered for a member have to become a new member. So it is why that a person can have a multiple customer table and become a multiple. Or maybe a person was upgraded the status of the customer have been upgraded from uh, from condition 1 to into condition 2 also. So this is one of the reason why the normalized database is necessary. So unlike the database in the data warehouse where you don't need this kind of uh, relationship, you need to simplify the table to become a meaningful table. So sometimes you need to rejoin multiple table into a single table. So it will be uh, creating redundancy data, and it's okay as long as the information is not changed, and as long as the information still remain the same with the previous data. So this is the example of star sim database. Okay, why do this sim called as a star database? As you can see that a single table surrounded by another table outside the table, and it forming like a star. So this is the main reason why the sim called star, because the shape of the database looks like a star. And also, if you notice carefully, then you will find that the table name was different. The middle table name was started with the word fact, and for the outside table started from the word dim, which is stand for dimension. So in the main requirement to design a database for a data warehouse is you need at least one fact table and then at least one dimension table. So let me try to explain it more broader. Why do we need this dimension, and why do we need this fact? Basically, fact table stand for not stand for. Basically, the fact table will be consist of the transactional data, okay, and dimension table will be consist of the point of view of the transactional itself. To explain more about the transactional data, let's say product dimension. What do we need? Why do we need the product as a dimension? Let's say we wanted to know which product having the highest seller for the whole year, or which product being sold, or which product never been sold, or which product having the lowest transaction. So that way, we are using the product as a dimension. And what about the promotion dimension? Let's say we wanted to know what kind of promotion promote the highest transaction. What kind of promotion promote the lowest transaction the whole year? Having those kind of conditions will make it simpler, will make it easier, will make it faster, efficiently, because we are collecting the data based on the simple needs, such as the promotion or such as the product. Can we combine those dimensions? Yes, of course, we can combine the dimension. Let's say we try to combine between the product dimension and the promotion dimension. So the big question is, which product have been sold during the promotion week? What kind of product having the highest seller, the highest sell, or the highest transaction during the promotion week? Can we combine with another dimension? Of course we can. Let's say the sales territory, which area that has the biggest or the highest transaction during the promotion that has a specific product. So you wanted to do that, then it can be easily without the need to join complex table or so on. Having this kind of condition, you can do a lot of new things to be discovered. Let's say which customer buys, or which customer having the highest transaction. When do the customer do the most transaction? Which promotion promote the highest transaction to that customer, and so on. And let's say the currency, what kind of currency that we use during those promotion. So it is very flexible and reliable concept if you wanted to explore more information within the data. So there is why you need an ETL to conduct this kind of condition, because you need to extract the data and then transform the data and then load the data, inject the data into the so basically the characteristic of a star sim would be the simplest and the most common use sim. So basically, most of the sim that being used in the data warehouse are using the star sim. And the center of the star sim will be called as the fact table that will be described what you are going to be analyzed. And for the surrounding table or the edge table will be called as the dimension table that will be described the basis of the analysis that you are going to use. one fact table can relate into one or more dimension table. So the characteristic will be the simple structure and easy to understand, and also it has a high query effectiveness because the number of join is small, very small, and it is the most commonly used seen in the data warehouse. This is for the advantage. And for the disadvantage of using the star sim would be it takes a long time to fill the data into the dimension table. Okay. And the data redundant causes a larger relative size. So this is compared to the snowflake. Even though that the differences is not so high, but still there is a difference. So the one that make it different is the time used to filling up the data into the dimension table, and also the data redundant uh, is higher in uh, a star sim than the snowflake sim. And for the snowflake sim, basically it's an extension of a star sim. Why I said so? Because as you see, this is the inner circle. The inner circle stand for the star sim, but because the snowflake is the extension of the star sim, then the dimension is being broadened or being extend into another dimension table. So it will become more specific than the previous the dimension, or we can say from the start sim. Let's say in the for the star sim previously we have only one dimension called date. Okay? If we wanted to know, or if we wanted to change the data or the date into a specific uh, condition, let's say quarter or semester and so on, then we need to modify it. We cannot do that kind of condition, and the information will only have for a specific date or a specific week or something. But if you are using the snowflake, then you need to specify those time into months. So we will have another group called as month, and also we will have another group called as a quarter. Means that this is stand for the 4 months. So if we wanted to know the sales for each quarter, let's say the quarter stand for January, February, March, April, and then the next quarter will be stand for May, June, July, August, and so on. Then we can classify the data into this kind of information. Or let's say we wanted to know the data monthly, then we can do that kind of PVT directly without the need to change the data. And also the standard version of the star sim itself, the time space dimension. So having this kind of concept or having this kind of condition has broadened up uh, the view of the information and having and it will give the user to have a lot of combination, a lot of a specific condition regarding to their needs, and also for the shop itself, whether it is grouped by the city or grouped by the region. So the main key concept is to extend the dimension is it should have the hierarchical structure. Okay? The uh, the closest the table uh, into the dimension table, then it will become more detailed, and the further the table, it will become more specific table. So you can see that this is timely or daily, and then which it is stand for monthly, and then it stand for the quarter. If you want it to change into tri-semester, and then you can have another like this. So it is allowed for you to have multiple uh, relationship like this one. Month being divided into quarter, and then being divided into tri-semester, and then divide into a semester, and so on. It is okay. Like this one, product being divided into product type, and then brand, and then the brand will be divided based on the supplier. So it is okay to have a multiple relationship. So that is why this kind of sim called as snowflakes, because the dimension have another dimension relationship. So the snowflake sim, as you know, and as already seen, that it has more a complex structure than a star sim. And also it is similar to star sim, but the dimension table are normalized, means that the dimension being breakdown into and having another relationship with the more with the specific dimension table. And having this kind of condition will facilitate the drill down concept or the drill down process and the analysis with a certain level of specificity or specification. Okay, what kind of drill down that we are dealing with? Let's say the cells, uh, let's say this is the time with the transaction, okay, and then we are having a view. So the drill down will be stand for this one as similar with the file explorer or Windows Explorer. We can break down into months, and then inside months we can break it down into a quarter or tri-semester or semester and so on. So it will have another hierarchy. So the advantage of this Snowflake sim that it will provide you a drill down time of report. Unlike the star sim where you cannot drill down because it will only be grouped by uh, the common use dimension. And this is the comparison between the normalized and normalized sim in Snowflake. So this is for the start sim where you are grouping or redundant or having a repeat data inside the repetition data inside a single record. Let's say it will be having a quarter and year and semester and so on. But when you are breaking it down into a Snowflake scene, then this kind of activity will be breaking down into another dimension table. As for example, the product will be break down into product category, and then the product category will be sorry, the product subcategory, and then it will be breaking down into the product category and so on. So having this kind of condition will give you flexibility, more flexibility, and wider information. The fact table and the dimension table. The fact table and the dimension table is mandatory to have when you are going to design a data warehouse sim. In this word, we call it as de facto, is mandatory to be used for the data warehouse. But not only in sim, but there are standards to make the fact table and the dimension table. So after we are creating, after we are designing, or after we choose the dimension table and the fact table, you need to know the criteria needs or the standard needs to make or to create a fact table and the dimension. So when we are injecting, putting or inserting the data into a fact table, then you need to understand that the fact table are the collection of the measurement related to a particular business process. The fact table itself are a collection of foreign key from the primary key contained in each dimension table. So the fact table also contain as contains historical data of a specific dimensional table. So there are four types of columns inside fact tables. Namely, the column will be stand as a foreign key and also the value or the score or the measures of the uh, of of the specific transaction, and another two, which is part of the fact table, and it is optional, means that you can use it or not. It will be depend on your needs. Okay, the third column will be called as a lineage, and the fourth column will be come as a business key column from the primary source table. And both of it, both of them are optional, means that you can use it or not. So basically, the two column will be used as a audit, and the data itself will not be shown or will not be shown to the user. So I will repeat it again once again. Then the third column and the fourth column is optional, and it is only being used for auditing the table or auditing the data, and the data itself will not be shown to the users because we only use these two column to verify the data that we have. So the fact table, let's say we have a product ID and then the employee ID. So as already being mentioned that it is a collection of a foreign key, then the fact table will be consist of a foreign key from a dimensional fact. And also it will be consist of a measurement column. The measurement, the first measurement will be stand for the total total sales or total value or total price or some others, and the other will be stand for the quantity or the amount or the number of the product sales or something. So it will be used to measure, or it will be used as the information that we that we need in the online analytical process. So it will be depend on the information that we use. So this is the two important column that you need to identify when you are going to load the the data into the data warehouse. And the second tables called dimensions table. And the dimension table is a table that contains detailed data that describes the foreign key contained in the fact table. And the attributes contained in the dimension table are made hierarchically to facilitate the query access. And there are 5 types of column in the dimension table, namely the key or the primary key, and then the name of the key to be used for human names of the entities, and then the attributes where we use this attribute to labeling or to analyze for pivoting or pivoting, and then the member properties, and then this is used to label or a label in a report, and then the last one would be called as a line edge column. And similar with the line edge column from the fact table, it is only being used for the auditing process and will never be exposed to the user. So let's say this is the dimension, product dimension. This is the ID of the primary key, or maybe you would like to have an alternative key. This is optional. And then the name of the product, it will be stand for the name column. And then the attribute of the dimension will representing the price. Okay. And maybe for the measurement, or maybe for the code that being used in the barcode, or the category others, it will be stand for the attribute. Okay, we will have a 10 minutes break during the azan or the call prayer.